There's a place just beyond the edges of our everyday awareness, a vast, swirling city of stars so immense it defies comprehension. Imagine a cosmic whirlpool stretching 100,000 light-years across, where billions of suns dance in the dark and entire worlds flicker like embers in the night. This is our Milky Way, a galaxy that feels familiar, yet hides secrets stranger than fiction. Even after centuries of staring into its depths, astronomers keep uncovering objects so bizarre, they challenge everything we thought we knew about the universe. Think of the galaxy as an endless attic packed with relics and oddities waiting to be stumbled upon. Some glow with the fury of 1,000 suns, others lurk unseen, bending time and space around them like cosmic pranksters. There are remnants of dead stars so dense, a teaspoon of their material would weigh more than a mountain, and colossal voids where gravity itself seems to switch off like a broken engine. And these aren't just anomalies, they're clues, whispering stories about the forces that shaped our galaxy and ultimately us. Today, we're setting off on a journey to 30 of the most mind-bending objects hidden in the Milky Way's shadowy corners. These aren't just distant curiosities, they're proof that reality outshines even our wildest sci-fi dreams. Some will make you question the laws of physics, others might just make you wonder what else is out there lurking just beyond our telescopes. So buckle up, by the time we're done, you'll never look at the night sky the same way again. Deep in the constellation Sagittarius, a cosmic predator spins at dizzying speeds, blasting its surroundings with a storm of lethal radiation. This is the Black Widow Pulsar, a neutron star so violent, it's slowly disintegrating its own stellar companion, atom by atom. Like its namesake spider, it's a ruthless killer, wrapped in the eerie glow of its victims' evaporating remains. Discovered in 1988 by astronomers scanning the gamma-ray sky, this pulsar isn't just dense, it's a rapidly spinning powerhouse completing over 600 rotations every single second. But the real horror unfolds in its gravitational grip. Locked in a death spiral just 2 million miles apart, closer than Mercury orbits the Sun, its smaller companion star endures an unthinkable onslaught. Particle winds scream outward at near light speed, scorching the star's surface, stripping away its outer layers like solar sandblasting. Over millennia, this relentless assault has whittled the star down to a shriveled, Jupiter-sized husk, glowing faintly under the pulsar's withering glare. What makes this system even stranger is the way it warps perception. The pulsar's beam sweeps past Earth like a lighthouse, flickering with eerie precision. But here's the twist: its gravity bends space-time so severely, the companion star's atmosphere acts like a lens, distorting the light in ways that made early observations seem impossible. It's a cosmic funhouse mirror, bending the rules of physics just to toy with us. And yet, the Black Widow isn't just destroying, it's creating. The shredded stellar material swirling around it forms a nebula of glowing plasma, fluorescing under the pulsar's harsh radiation. One day, the companion star will vanish entirely, leaving only a faint echo in the radio waves. Until then, this system remains one of the galaxy's most brutal reminders. Even among the stars, survival is never guaranteed. Hidden in the faint glow of a dwarf galaxy 3 billion light-years away, something is talking. Not with words, but with bursts of raw energy so powerful, they outshine entire galaxies for milliseconds at a time. This is FRB 121102, the first known repeating fast radio burst and one of the most tantalizing cosmic puzzles ever detected. Unlike one-off bursts that flash and vanish, this one keeps coming back, firing off signals in unpredictable patterns that defy all expectations. Each pulse packs more energy than our Sun emits in 3 days, yet lasts shorter than the blink of an eye. At first, astronomers wondered if they'd stumbled upon some alien megastructure, a beacon perhaps, or a malfunctioning warp drive. But the truth, as it often is in the cosmos, proved even stranger. The leading suspect, a highly magnetized neutron star called a magnetar, spinning so fast its magnetic field becomes a cosmic particle accelerator. Picture a lighthouse, but instead of light, it's shooting out twisting beams of radiation powerful enough to rip molecules apart. The repeating pattern suggests something else is at work. Maybe debris from a shattered planet swirling around the magnetar, or plasma clouds warping the burst like a funhouse mirror. What truly baffles scientists, though, is the burst's home. This dwarf galaxy barely holds 1% of the Milky Way's mass, yet it's a prolific FRB factory. Some think its young, chaotic environment, rich in newborn stars and supernova, creates the perfect crucible for these explosive events. Others speculate that the galaxy's low metal content lets magnetic fields grow to freakish strengths, turning ordinary neutron stars into celestial radio cannons. And then there's the timing. Some bursts arrive in frantic clusters, others after agonizing silences. It's as if the source is taunting us, dropping hints just out of reach. Every new detection rewrites the rulebook, proving the universe still holds cards we haven't even glimpsed yet. One thing's certain, whatever's lurking in that distant dwarf galaxy, it's rewriting what we thought was possible. Somewhere in the depths of the Milky Way, a dead star has turned its companion into the ultimate cosmic trophy, a planet-sized diamond sparkling in the eternal night. Meet PSR J1719-1438b, a world so dense and exotic, it makes even the most lavish earthly jewels look like grains of sand. This story begins with a violent ending. A massive star, having burned through its fuel, collapsed under its own gravity, detonating in a supernova so powerful, it left behind only a rapidly spinning corpse, a pulsar. But this pulsar didn't drift alone. Once it shared its orbit with another star, a carbon-rich giant. As the pulsar's gravity clawed at its companion, it siphoned away layers of gas, whittling the star down to a fraction of its former size. What remained was the star's core, a chunk of carbon so compressed under unimaginable pressures that it crystallized into something extraordinary, a diamond 5 times the size of Earth. Imagine a world without mountains, oceans, or atmospheres, just an endless, flawless crystal stretching beneath a sky dominated by the pulsar's relentless glare. The pressure at its core is so intense, carbon atoms lock together in perfect lattices, forming a structure far harder than any diamond we've ever forged on Earth. Yet this gemstone giant isn't just sitting there. It whips around its pulsar at breakneck speed, completing an orbit in just over 2 hours. So close that tidal forces have stretched it into a football shape, forever straining under the pulsar's gravitational grip. What's truly mind-bending is how we even found this celestial jewel. Astronomers detected it not by its shine. It emits almost no visible light, but by the way its gravity tugs on the pulsar, creating tiny irregularities in the star's clockwork radio pulses. The discovery rewrote textbooks. Planets weren't supposed to survive supernova, let alone transform into cosmic diamonds. Yet here it is, a glittering relic of stellar cannibalism, proving that even in destruction, the universe crafts beauty beyond our wildest dreams. Deep in the heart of the Milky Way, where the galaxy's core churns like a cosmic storm, there's a monster that doesn't just consume matter, it obliterates it with a ferocity that defies logic. This is the Great Annihilator, a black hole so voracious it rips atoms apart and hurls their antimatter remains back into the void. Officially catalogued as 1E1740.7-2942, its nickname isn't just dramatic flair, it's a literal description of the particle Armageddon unfolding around it. Unlike most black holes that swallow everything in shadowy silence, this one announces its feasts with twin jets of gamma rays screaming into space at near light speed. These aren't ordinary outbursts. When matter spirals into the black hole's accretion disk, superheated to millions of degrees, something extraordinary happens. Electrons and their antimatter counterparts positrons collide in a frenzy, annihilating each other in bursts of pure energy. It's like tossing gasoline into a bonfire, except the flames are made of particles that shouldn't exist outside of labs on Earth. What makes the Great Annihilator even stranger is its location. Nestled just 300 light-years from Sagittarius, a star, our galaxy's supermassive black hole, it's like a smaller, hungrier sibling acting out in the cosmic playground. Astronomers first detected it in 1992, not by sight. It's hidden behind thick interstellar dust, but by the gamma-ray fireworks it unleashes. Even now, decades later, its behavior remains unpredictable. Some days it's a glutton, devouring whole streams of gas. Other times it falls eerily quiet, as if taunting scientists trying to decode its secrets. But here's the real kicker. Those antimatter jets aren't just blazing into emptiness. They sculpt the space around them, ionizing nearby gas clouds and creating shockwaves that ripple across light years. It's a stark reminder that black holes aren't just vacuum cleaners of the cosmos, they're alchemists, transforming matter into energy and energy into mysteries we're only beginning to comprehend. One thing's certain, in the Great Annihilator's realm, the laws of physics don't just bend, they shatter. Most stars live their lives in quiet orbits tethered to the galaxy by gravity, but not Zeta Ophiuchi. This blue giant is a cosmic fugitive, hurtling through space at nearly 100,000 miles per hour, leaving a fiery bow shock in its wake like a ship plowing through invisible seas. Born in a cluster of sibling stars, Zeta Ophiuchi's wild journey began with a violent betrayal. Once, it orbited an even more massive companion, a star destined to die young. When that companion exploded as a supernova, the blast was so powerful, it literally kicked Zeta Ophiuchi loose, flinging it across the galaxy like a pebble from a slingshot. The force was unimaginable enough to overcome the gravitational bond that had held the stars together for millions of years. Now, this runaway star races alone, its brilliant blue light staining the dust clouds around it with an eerie glow. What makes Zeta Ophiuchi truly spectacular isn't just its speed, it's the trail of chaos it leaves behind. As the star rams through interstellar gas at supersonic speeds, it compresses the material ahead of it, heating it until it shines in infrared light. From our vantage point, this creates a vast, curved shockwave, like a cosmic fingerprint smeared across the darkness. The star's fierce stellar winds particles streaming from its surface at over 2 million miles per hour sculpt the gas into intricate ripples and swirls, visible only to telescopes that peer beyond the visible spectrum. Yet the most tantalizing question remains: where is the corpse of the star that launched this runaway? The supernova's remnant should still linger somewhere in the void, a neutron star or black hole drifting in the opposite direction. But despite decades of searching, astronomers haven't found it. Maybe it's hidden behind thick dust clouds, or perhaps it was ejected even faster, vanishing into the galactic dark. Whatever the case, Zeta Ophiuchi's frantic flight stands as a ghostly reminder even among the stars. Violence writes the most dramatic escape stories. Right now, 2.5 million light-years away, a cosmic predator is creeping toward us in the dark, not a black hole or rogue planet, but an entire galaxy with a taste for destruction. The Andromeda galaxy, our nearest spiral neighbor, isn't just drifting aimlessly through space. It's a galactic cannibal, its history written in the corpses of smaller galaxies it has devoured over billions of years. Hubble Space Telescope observations reveal Andromeda's gruesome secret: vast streams of stars stretched like taffy across its outer edges. The torn apart remains of at least 2 dwarf galaxies it absorbed long ago. These stellar rivers, invisible to the naked eye, are the smoking gun of cosmic predation. As smaller galaxies ventured too close, Andromeda's immense gravity ripped them apart, scattering their stars into eerie, looping trails. One victim, a dwarf galaxy called M32, was nearly annihilated, reduced to a dense, compact core that now orbits Andromeda like a ghostly trophy. But here's the twist. The Milky Way is no innocent bystander. We've done our own share of galactic snacking, having absorbed at least a dozen smaller galaxies over the eons. The difference: Andromeda is bigger, hungrier, and heading straight for us at 250,000 miles per hour. In roughly 4.5 billion years, the two galaxies will collide in a slow-motion crash so vast it'll rewrite the night sky forever. Stars won't actually smash into each other. Space is too empty for that, but gravity will twist both galaxies into a spectacular dance. Computer simulations show spiral arms shredding into tidal tails, new stars igniting in shockwaves of gas, and the two supermassive black holes at their cores spiraling toward an eventual merger. The end result: a single, colossal elliptical galaxy astronomers have nicknamed Andromeda. Our solar system will likely survive, but it'll be flung into a new orbit, and the familiar constellations we know today. They'll be obliterated, replaced by a sky ablaze with unfamiliar stars. What's truly humbling is the timescale. This merger has already begun in a cosmic sense. The first wisps of Andromeda's outer halo are already brushing against our own. Yet by the time the galaxies fully coalesce, Earth's oceans will have boiled away, the sun will be a dying red giant, and any humans left will witness the finale from a radically transformed world. Andromeda's hunger reminds us, galaxies aren't static islands in space. They're living, evolving beasts growing by consumption. And one day, our Milky Way story will end with its light dissolving into the belly of a larger beast. Until then, we're left with a front-row seat to the most epic slow-motion collision in the universe. In the vast, swirling tapestry of the Milky Way, where scorching stars and searing nebulae dominate the scene, there's a frozen oddity that defies the very laws of cosmic thermodynamics. The Boomerang Nebula isn't just cold. It's the coldest known place in the entire universe, a chilling -272 degrees Celsius. That's just 1 degree warmer than absolute zero, the theoretical temperature where all atomic motion stops. To put that in perspective, even the empty void between galaxies hovers around -270, making this nebula an icy anomaly in a cosmos that generally trends toward heat. What makes this cosmic deep freeze even stranger is its origin story. Located 5,000 light-years away in the constellation Centaurus, the Boomerang isn't a typical nebula born from stellar explosions. Instead, it's the death shiver of a dying sun-like star, one that's shedding its outer layers at a staggering speed of 370,000 miles per hour. As the star's gas tears away into space, it expands so rapidly that it cools to temperatures lower than the natural background chill of the universe. Imagine opening a freezer door so violently that the rush of escaping air freezes everything around it, only on a scale that dwarfs our solar system. But there's another twist: the nebula's eerie, symmetrical shape. Hubble telescope images reveal two near-identical lobes of gas stretching outward, giving it the appearance of a cosmic hourglass, or, as its name suggests, a boomerang in flight. This bipolar outflow happens when the dying star's material gets funneled into twin jets by a dense disk of dust surrounding its equator. The result is a structure so precise it looks almost sculpted. Here's where things get even weirder. In 2017, astronomers discovered the nebula's cold heart hides a secret, a hidden stellar companion. The primary star, now a faint white dwarf, likely siphoned material from its partner, triggering chaotic outbursts that shaped the nebula's iconic form. This stellar dance created shockwaves that further cooled the expanding gas, turning the Boomerang into a cosmic refrigerator. Yet the coldest spot isn't even at the nebula's center. It's in the ghostly filaments of gas at its outermost edges, where expansion has stretched molecules so thin they barely interact. In these frigid outskirts, even the faint whisper of residual heat from the Big Bang is overpowered. That makes the Boomerang more than just a celestial curiosity. It's a natural laboratory for testing physics at the edge of possibility. and there's a sobering footnote to this frosty marvel. In a few thousand years, the nebula will warm as its gas disperses into the interstellar medium. The universe, it seems, has no patience for permanence, not even for its most extreme records. For now, though, the Boomerang Nebula stands as a haunting reminder that even in the fiery chaos of the cosmos, coldness can carve its own legacy. Rising from the cosmic dust like an ancient monolith, the Red Rectangle Nebula stands as one of the Milky Way's most perplexing geometric wonders. Located 2,300 light-years away in the constellation Monoceros, this glowing structure doesn't just defy the usual chaos of stellar death. It mocks it, presenting near-perfect symmetry where science expects only turbulence. Its name undersells the spectacle. Hubble telescope images reveal an intricate lattice of glowing gas, struts, and rungs forming an unmistakable X shape, as if some celestial architect drafted blueprints for the universe. At the heart of this cosmic geometry lies a binary star system, two aging suns locked in a gravitational waltz. The primary star, HD 44179, has exhausted its hydrogen fuel and now sheds its outer layers in erratic bursts. But here's the twist. Instead of forming the usual spherical or spiral patterns seen in planetary nebulae, the ejected material gets funneled into twin cones by a thick dust disk encircling the stars. Picture two colossal ice cream cones placed tip to tip, their edges glowing crimson as starlight scatters through carbon-rich molecules. This precise alignment, almost exactly edge-on from Earth's perspective, gives the nebula its rectangular illusion and haunting cross shape. What's truly baffling is the scale of this order. Most dying stars spew debris in chaotic plumes, yet the red rectangle's structure remains unnervingly stable. Astronomers suspect the binary star's orbital dance acts like a cosmic metronome, regulating the outflow with clockwork precision. Every 650 days, as the stars swing closest together, their combined gravity tugs at the surrounding disk, ejecting fresh material in synchronized bursts. Over millennia, these pulsars have sculpted the nebula's iconic ladder like rungs, each one a fossilized record of stellar tantrums long past. Then there's the color. The nebula's eerie red glow comes not from hydrogen, the usual suspect in cosmic light shows, but from a rare phenomenon called extended red emission. As ultraviolet light from the dying stars bombards microscopic carbon grains in the dust, the particles fluoresce, emitting a deep, bloody hue. This spectral fingerprint suggests the nebula's chemistry is as peculiar as its shape, packed with complex organic molecules that some scientists speculate could seed life elsewhere. Yet the red rectangle guards its ultimate secret fiercely. No current model fully explains why the nebula's geometry persists while others dissolve into randomness. Some theorize magnetic fields act as invisible scaffolding, while others propose undiscovered planets shaping the flow from within the disk. Even its fate is a mystery. In a few thousand years, the central stars will heat up, ionizing the gas and erasing the structure forever. For now, this cosmic cathedral of dust and light remains a silent rebuke to our assumptions, proving that even in death, stars can create art beyond human imagination. Astronomers have a name for objects that should have been ripped to shreds: Object G2. This cosmic enigma is a swirling mass of dust and gas that did the unthinkable. It survived a near miss with the ravenous mouth of Sagittarius, a star, the supermassive black hole at the Milky Way's core. Most celestial bodies venturing that close don't just get stretched, they get erased from existence. But G2, it laughed in the face of gravity's worst tantrum and drifted away intact, rewriting our playbook on how matter behaves under extreme conditions. Discovered in 2011, G2 was initially dismissed as just another doomed gas cloud. Calculations showed its orbit would bring it perilously close to the black hole's event horizon. Close enough to trigger a violent process called spaghettification, where tidal forces pull objects into noodle-thin streams. Astronomers set their telescopes for a front-row seat to cosmic destruction. expecting a brilliant flare as the black hole devoured its snack. But when G2 made its closest approach in 2013, something bizarre happened. Instead of being torn apart, it wobbled, stretched, and then kept going like a rubber band snapping back into shape. The implications sent shockwaves through astrophysics. If G2 wasn't a simple gas cloud, what was it? Some researchers now believe it hides a stealth star cloaked in thick shrouds of dust. The theory goes that this star, possibly formed during a chaotic stellar collision near the galactic center, drags an enormous veil of gas along its orbit. When the black hole's gravity squeezed the system, the star's gravity held the gas together just enough to resist total disintegration. It's like watching a kite survive a hurricane because its string never quite snapped. Even stranger is G2's behavior afterward. Instead of fading into obscurity, it's shown peculiar changes in brightness, flickering in infrared like a smoldering ember. Some suspect the close call heated trapped gas within the dust envelope, causing it to glow a cosmic fever from its near-death experience. Others point to the object's stretched, elongated shape, now resembling a comet's tail, as evidence of ongoing interactions with the black hole's environment. But here's the real mystery. G2 isn't alone. At least 5 other G objects have been spotted in similar orbits, all behaving like cosmic rubber balls bouncing around a bottomless pit. Are these failed stars stellar mergers in disguise, or something entirely new, a class of objects we've never imagined? Each one challenges the dogma that black holes are indiscriminate destroyers, hinting that even their gravitational might has limits. One thing's certain, the galactic center isn't just a graveyard, it's a laboratory where physics gets pushed to its breaking point. And G2, the unkillable cosmic traveler, is its most stubborn test subject yet. Some stars flicker gently, their light wavering like candles in a breeze, but KIC 8462852, better known as Tabby's star, doesn't flicker. It plunges. Imagine a sun that occasionally dims by up to 22%, as if something colossal is repeatedly passing in front of it, blotting out its light in jagged, unpredictable patterns. Discovered in 2015 by citizen scientists sifting through Kepler Space Telescope data, this star isn't just unusual, it's a cosmic anomaly that made astronomers question everything from dust clouds to alien engineering. At first glance, the star located 1,500 light-years away in Cygnus seems ordinary, a yellow-white dwarf slightly larger and hotter than our Sun. But its light curve tells a different story. Most exoplanet discoveries involve regular, symmetrical dips as planets transit. Tabby's star, its dips are erratic, deep, and asymmetrical. Some last days, others weeks, with no discernible rhythm. The deepest recorded drop swallowed nearly a quarter of the star's light, something no known planet could cause. Even stranger, long-term studies show the star's overall brightness has been fading for over a century, declining by an unprecedented 14%. Cue the alien megastructure theories. When Penn State astronomer Jason Wright first saw the data, he noted the dimming patterns loosely matched what you'd expect from a Dyson swarm, a hypothetical array of energy-collecting satellites built by an advanced civilization. The idea wasn't entirely fringe. The Kepler mission was designed to spot unnatural signatures, and here was a star behaving unnaturally. Media erupted, and for a moment the world wondered, had we found evidence of cosmic neighbors? But science thrives on skepticism. Follow-up observations revealed no telltale radio signals or laser pulses. Instead, newer studies pointed to dust, lots of it. Spectroscopic data showed the dimming events affected blue light more than red, a classic sign of fine particles scattering shorter wavelengths. The leading theory now suggests a fractured exoplanet or a swarm of comets was torn apart by the star's gravity, creating a vast, uneven debris field. As clumps of this material orbit, they cast irregular shadows, yet the mystery persists. Why is the dust so uneven? Why does the century-long dimming contradict typical stellar behavior? Some propose a colossal collision between planets, leaving behind a chaotic debris disk. Others speculate the star itself is unstable, engaging in bizarre magnetic activity. And yes, a few still whisper about alien megaprojects, not as a likely answer, but as a reminder of how little we truly understand. Tabby's star endures as a humbling lesson. In a universe where we've mapped billions of galaxies, one unassuming star in our cosmic backyard still defies explanation. Every new observation peels back another layer, revealing not answers but deeper questions. Whether it's dust, wrecked worlds, or something beyond our imagination, this star refuses to be pigeonholed, and that's what makes it extraordinary. Most galaxies come in predictable shapes, spirals with elegant arms, ellipticals like cosmic blobs, or chaotic irregulars. Then there's Hoag's object, a celestial oddity so flawless it looks like it was drawn with a compass. Floating 600 million light-years away in the constellation Serpens, this ring galaxy is a perfect circle of young, blue stars encircling an older, golden core, separated by a yawning gap of near-total darkness. No spiral arms, no messy distortions, just a cosmic bull's-eye hanging in the void, defying every expectation of how galaxies form. Discovered by astronomer Arthur Hoag in 1950, this structure was so bizarre he initially speculated it might be a gravitational lensing illusion. But decades of observations confirmed its reality and deepened the mystery. The ring, spanning 120,000 light-years larger than our Milky Way, blazes with the light of massive, short-lived stars, suggesting rampant star formation. Meanwhile, the central core glows with the reddish hue of ancient stars, as if two completely different galaxies were welded together. Stranger still. The gap between them isn't empty, it's filled with faint, dusty filaments too dim for early telescopes to detect, hinting at a violent past we're still piecing together. How does something so symmetrical exist without the usual galactic scaffolding? One leading theory involves a galactic collision billions of years ago. Picture a smaller galaxy plunging straight through a larger one's center, like a bullet through an apple. The impact would send shockwaves rippling outward, compressing gas into a star-forming ring while leaving the central bulge relatively undisturbed. Computer simulations show these bullseye collisions are possible, but they require freakishly precise angles and speeds. The alternative, a rare instability called a resonance ripple, where density waves in a spinning galaxy gather material into a perfect circle, like a phonograph record warping into a ring. Yet Hoag's object refuses to fit neatly into any box. In 2021, Hubble Space Telescope data revealed an even stranger twist, another fainter ring galaxy, possibly a sibling, lurking even farther out in the same field of view. Are they cosmic relatives born from the same cataclysm, or just an eerie alignment? And why does the inner ring show chemical signatures suggesting multiple generations of stars, as if it's been recycling material for eons? The most humbling part, we've found fewer than 20 galaxies resembling Hoag's object in the observable universe. It's a galactic unicorn, a structure so rare it challenges our statistical models of cosmic evolution. Maybe that's the lesson here. In a universe built on chaos and collisions, perfection isn't just rare, it's a rebellion against the norm. And Hoag's object, with its serene, unbroken circle, remains the universe's quietest revolutionary. Galaxies without dark matter shouldn't exist, at least. That's what every cosmological model insisted. Then along came NGC 1052-DF2, a ghostly smudge in the constellation Cetus that turned astrophysics upside down. This ultra-diffuse galaxy, floating 65 million light-years away, isn't just faint. It's missing 99.99% of the invisible glue scientists believed held all galaxies together. First spotted in 2018 by the Dragonfly telephoto array, DF2 looked like a cosmic afterthought, a sparse collection of stars so spread out you could fly through it for light years without spotting more than a handful of suns. But when researchers measured the motions of its globular clusters, tight knots of ancient stars orbiting the galaxy's outskirts, they got a shock. Those clusters were moving far too slowly. According to Newton's laws, such sluggish speeds meant DF2's mass had to be almost entirely from its visible stars, with barely any contribution from dark matter. It was like finding a skyscraper standing tall with no foundation, defying gravity itself. The discovery ignited a firestorm. Dark matter is supposed to be the cosmic scaffolding. Without it, gas couldn't condense enough to form stars in the early universe. Yet here was DF2, flaunting its emptiness like a cosmic rebel. Skeptics scrambled for alternatives. Maybe DF2's dark matter halo was stripped away by a violent encounter with a neighboring galaxy, or perhaps our measurements were skewed by an unusual viewing angle. But further study only deepened the mystery. The galaxy's stars showed no signs of tidal disruption, no scars from a cosmic collision, and its sibling, DF4, displayed the same eerie lack of dark matter, ruling out a fluke. Then came the plot twist. In 2021, revised distance measurements suggested DF2 might be closer than originally thought, which would mean its stars are intrinsically dimmer, reducing the need for dark matter to explain their motion. But this solution raised new questions. If DF2 is nearby, why does its redshift match the NGC 1052 group, implying it's far away? And why do other independent methods still support the original distance? The debate rages on, splitting astronomers into camps. What makes DF2 so tantalizing isn't just its defiance, it's the possibilities it forces us to confront. Could dark matter interact in ways we haven't imagined, leaving some galaxies empty? Or does its absence hint at alternative theories of gravity, like modified Newtonian dynamics? Every new observation peels back another layer, revealing not answers but deeper fractures in our understanding. For now, DF2 remains a cosmic ghost story, a whisper that the universe's hidden rules might be far stranger than we dreamed. Floating just 200 light-years from Earth in the constellation Libra, a seemingly ordinary star has upended our understanding of cosmic history. Known as the Methuselah star, HD 140283 looks like a faint speck to the naked eye, but its true significance lies in what astronomers discovered when they measured its age. This ancient relic is approximately 14.5 billion years old, a number that sends shockwaves through cosmology because it's older than the universe itself. The paradox begins with the star's composition, a metal-poor subgiant made almost entirely of hydrogen and helium, the primordial elements forged in the Big Bang. Unlike younger stars crammed with heavier elements from supernova explosions, Methuselah's near-pure makeup signals it was born in the cosmic dawn, when the universe was still in its infancy. Pinpointing its age required painstaking analysis of its brightness, distance, and nuclear burning rates, a celestial detective job spanning decades. Early estimates pegged it at a staggering 16 billion years, a figure that clashed violently with the universe's then-accepted age of 13.8 billion. Cue the existential crisis. How could a star exist before the universe that birthed it? The discrepancy forced astronomers to re-examine every assumption. Some suggested errors in stellar models. Maybe the star's interior mixed differently, skewing calculations. Others questioned the Hubble constant, the value used to measure cosmic expansion rates. The most startling realization: our cosmic clock might need recalibration. Revised measurements using updated parallax data from the Hubble Space Telescope later adjusted Methuselah's age downward slightly, but even the most conservative estimates still placed it within a hair's breadth of the universe's age. This razor-thin margin hints at something profound. Our understanding of the early universe remains incomplete. The star's longevity might be tied to exotic physics, perhaps a lower oxygen content than initially thought, slowing its aging process, or interactions with a yet undetected companion star. What makes Methuselah truly humbling is its resilience. It has outlived countless generations of stellar siblings, drifting through the galaxy as a living fossil. Its light, now reaching us, carries whispers from an era before spiral galaxies formed, before planets coalesced, a time so distant its memory exists only in the nuclear alchemy of this single, stubborn survivor. The star's defiance of cosmic timelines isn't just a puzzle, it's an invitation to rewrite the story of everything. Above and below the Milky Way's bustling core, two colossal orbs of searing energy loom like silent sentinels, each stretching 25,000 light-years into the void, pulsing with gamma rays strong enough to vaporize planets. These are the Fermi bubbles, named for the telescope that discovered them in 2010, and they're not just any cosmic structure. They're the scorching aftermath of a cataclysm so violent it may have reshaped our galaxy's destiny. At first glance, the bubbles resemble an hourglass tipped on its side, their edges sharp as knife cuts against the faint glow of interstellar gas. What makes them extraordinary isn't just their size, enough to engulf half the visible sky if our eyes could see gamma rays, but their energy. The particles inside rage at millions of degrees, screaming into space at nearly the speed of light. For decades, these bubbles went unnoticed, hidden behind the Milky Way's dense disk of dust and stars. It took Fermi's specialized gamma-ray vision to peel back the veil, revealing a pair of cosmic bruises that shouldn't exist. The leading theory: a prehistoric temper tantrum from Sagittarius, a star, the supermassive black hole at our galaxy's heart. Roughly 2 to 4 million years ago, something massive, perhaps a wayward gas cloud or a doomed star, plunged into the black hole's maw. Instead of swallowing its meal quietly, Sagittarius, a star, belched out twin jets of ultra-hot plasma, punching through the galactic disk like a cosmic cannon. The shockwaves from that eruption would have ripped apart nearby star systems, ionized vast swaths of interstellar gas, and flooded the Milky Way with radiation for millennia. The Fermi bubbles are the fossilized remnants of that explosion, their still glowing walls a testament to the black hole's past fury. But here's where the mystery deepens. The bubble's gamma rays aren't uniform. They're clustered in bizarre, filament-like structures near the edges, as if something is accelerating particles there like a natural collider. Some researchers argue these filaments point to an even wilder origin, not a single eruption but repeated outbursts over eons, each adding another layer to the bubble's eerie anatomy. Others suggest the bubbles might be fueled by dark matter annihilations, with hypothetical particles colliding and decaying in bursts of energy, the most unsettling possibility. This could happen again. Sagittarius, a star, is relatively quiet now, but if another massive object wanders too close, the Fermi bubbles might just get a violent sibling. Until then, these towering relics serve as a humbling reminder. Even our galaxy's calm exterior hides a history of rage written in gamma rays. On the night of August 15, 1977, a radio telescope in Delaware caught something that would haunt astronomers for decades. A 72-second burst of sound so peculiar, the scientist who discovered it scrawled, "Wow." In red ink on the printout, that single word gave the signal its name, but the real mystery lay in the data. The narrowband radio spike matched the expected signature of an artificial transmission, blaring at the exact frequency hydrogen absorbs and emits energy, a logical choice for any civilization trying to announce its presence. Then, just as suddenly as it appeared, the signal vanished, never to repeat despite 40 years of searching. What makes the WOW signal so unnerving isn't just its fleeting nature, it's where it came from. The burst originated near the Chi Sagittarii star group, a patch of sky devoid of known planets or obvious natural radio sources. Even stranger, the signal's intensity followed a perfect bell curve as the telescope's receiver drifted across it, suggesting a pinpoint origin rather than random cosmic noise. Over the decades, explanations have ranged from the mundane, a passing comet's hydrogen cloud, to the extraordinary, an alien beacon flickering on for just over a minute. Yet every proposed solution crumbles under scrutiny. The comet theory, the alleged object wasn't even in the right part of the sky, a secret military transmission. No earthly technology matched the signal's unique profile. Fast forward to the 21st century and the WOW signal has company. In 2020, astronomers detected a bizarre radio burst from Proxima Centauri, the closest star system to Earth. Dubbed BLC-1, this signal shared eerie similarities with WOW, a narrowband emission at hydrogen's frequency with no natural explanation. Unlike WOW, BLC-1 repeated sporadically, but always from the same patch of sky near our nearest stellar neighbor. The kicker, Proxima Centauri hosts at least one rocky planet in the habitable zone. Could this be a cosmic flare or something more deliberate? The answer remains elusive, buried in layers of interference and statistical noise. Then there's the even stranger case of fast radio bursts brief, intense pulses of energy from galaxies billions of light years away. While most FRBs are likely natural, one named FRB 120116 stands out. It not only repeats but does so in a predictable cycle, flaring up every 157 days like clockwork. No known celestial object behaves this precisely, sparking theories about wobbling neutron stars or even, once again, alien megastructures. The truth, we're still groping in the dark. What ties these signals together is the unnerving gap between natural and artificial explanations. Cosmic phenomena like pulsars and magnetars produce radio waves, but rarely with the specificity of WOW or BLC-1. Human-made interference is always a suspect, yet the most tantalizing signals emerge from regions where no satellites or aircraft operate. The real lesson here might be humility. In a universe teeming with unexplained noise, the line between a cosmic coincidence and a hello from the void is vanishingly thin, and that's what keeps astronomers listening. In the southern constellation of Carina, a cosmic time bomb ticks away, one so bright it outshone every star in the Milky Way for years. Eta Carinae isn't just another hypergiant, it's a celestial powder keg, a luminous blue variable so unstable, its tantrums have rewritten the rules of stellar behavior. This star doesn't just burn, it rages, with a luminosity 5 million times that of our Sun, and a mass teetering on the brink of self-destruction. The most infamous chapter in Eta Carinae's chaotic history unfolded in the 1840s, an event astronomers now call the Great Eruption. For over a decade, this star became the second brightest object in the night sky, visible even in broad daylight, a feat unmatched by any stellar outburst since. But here's the twist, it didn't explode. Instead, Eta Carinae belched out enough material to forge 20 suns, ejecting twin lobes of gas and dust at speeds approaching 4 million miles per hour. Today, those ejecta form the Homunculus Nebula, a ghostly hourglass of stellar debris so vast, light takes 8 years to cross it. What triggered this cosmic tantrum? Theories range from a near-fatal gravitational tug-of-war between Eta Carinae and an unseen companion star to internal instabilities in the star's core. Some simulations suggest the star's outer layers became so bloated with radiation pressure they effectively boiled over, like a pot left too long on a cosmic stove. Others propose the eruption was a desperate last gasp, a failed supernova where the star nearly tore itself apart but somehow clung to existence. But the real danger lies in what comes next. Luminous blue variables like Eta Carinae are stellar dead men walking, destined to implode as supernova or even hypernova within astronomical eye blinks. When this star finally goes, the explosion could outshine the full moon, bathing Earth in enough ultraviolet radiation to ionize our upper atmosphere. Some models suggest it might unleash a gamma-ray burst, a lethal jet of energy capable of sterilizing nearby solar systems, yet Eta Carinae keeps defying predictions. Its last major flare-up in 2018, a sudden brightening caught by telescopes worldwide, hinted that the star's death throes could be stranger than anyone imagined. For now, it looms as a cosmic question mark, a reminder that even the mightiest stars don't always die by the rules. Drifting alone through the interstellar void, far from the warmth of any sun, there's a world that defies the very definition of a planet. CFB DSIR 2149-0403 isn't just another distant exoplanet, it's a cosmic renegade untethered to any star, wandering the galaxy like a ghost in the dark. Most planets orbit a parent star, bound by gravity's unbreakable chain, but this one, it answers to no one. Discovered in 2012 by astronomers scanning the infrared sky, this rogue planet floats just 130 light-years away in the constellation Aquarius. At roughly 4 to 7 times Jupiter's mass, it's too small to be a brown dwarf, those failed stars that flicker faintly on their own yet too massive to fit neatly into traditional planet categories. What makes it truly extraordinary is its temperature, a scorching 400 degrees Celsius, glowing dull red from the residual heat of its violent birth. Without a star to warm it, this heat should have bled away eons ago, suggesting the planet is shockingly young, maybe only 50 million years old, a mere infant by cosmic standards. Theories about its origins read like a thriller's plot twists. Perhaps it was violently ejected from its home system during the chaotic gravitational tug of war of planet formation, a cosmic game of pinball where the loser gets flung into the abyss. Or maybe it formed in isolation, condensing directly from a collapsing gas cloud like a starless understudy. This second scenario rattles the foundations of planetary science, challenging the long-held belief that planets are always born in the dusty disks around young stars. Then there's the eerie atmosphere. Spectroscopy reveals a sky choked with methane and water vapor, swirling in storm systems that might never feel sunlight. If you could stand on this world's surface, assuming it has one beneath its thick, gaseous layers, the sky would be a starless black, punctuated only by the faint glow of passing nebulae, no sunrise, no sunset, just perpetual night. Yet the most tantalizing question isn't how it got there, it's how many more are out there. Current estimates suggest rogue planets could outnumber stars in the Milky Way by a staggering margin, a hidden population of drifters crisscrossing the galaxy unseen. Some might even harbor subsurface oceans, kept liquid by radioactive decay or tidal forces from ancient moons, turning the concept of habitable zones on its head. CFB DSIR 2149-0403 is more than a curiosity, it's a harbinger of the galaxy's hidden chaos, proof that the universe still plays by rules we're only beginning to decipher. In its solitude, it whispers a humbling truth. For every orderly solar system, there might be 100 lost worlds adrift in the dark, rewriting what it means to be a planet. Rising from the Milky Way's heart like twin tsunamis of fire, the galactic geysers are among the most colossal structures ever discovered in our home galaxy. These towering fountains of superheated plasma stretch an astonishing 25,000 light-years above and below the galactic plane, far enough to engulf the entire night sky if our eyes could perceive their faint X-ray glow. Unlike the Fermi bubbles, which are static remnants of past explosions, these geysers are alive, churning with enough energy to power 1 billion suns, all fed by the insatiable appetite of Sagittarius, a star, the supermassive black hole at our galaxy's core. The discovery, made in 2019 by the EHMC telescope array, revealed a spectacle no one expected: vast tendrils of charged particles, accelerated to near light speed, erupting from the galactic center like water blasted through a cosmic hose. Each geyser's base spans hundreds of light-years, funneling material outward at velocities so extreme they defy even the black hole's gravity. What's fueling them? The leading theory points to a brutal cycle of destruction and rebirth. As stars, gas clouds, and asteroids spiral into Sagittarius, a star's accretion disk, their energy doesn't just vanish. It's converted into colossal magnetic fields that twist and snap like rubber bands, slingshotting particles into the void. But here's the twist. The geysers aren't just blowtorches of random chaos. Their structure is eerily organized, with filaments braided like ropes and shockwaves rippling through the plasma in predictable patterns. Some astronomers compare them to the jets seen in distant quasars, albeit on a smaller scale. This hints at something profound. Our quiet black hole might once have been a miniature quasar itself, erupting in fits of violence that shaped the Milky Way's evolution. The most baffling feature lies at the geyser's edges, where the plasma collides with the galaxy's halo of dark matter. Instead of dissipating, the particles seem to pile up, creating glowing caps of X-ray emission. These caps act like cosmic pressure valves, preventing the energy from escaping entirely, a self-regulating system no one knew existed. What does this mean for our galaxy? The geysers are more than a light show. They're a galactic recycling program. The ejected material, enriched with heavy elements from stellar debris, eventually rains back down onto the Milky Way's disk, seeding future generations of stars and planets. In a way, we might owe our existence to these ancient eruptions, yet their full story remains unwritten. Each new observation peels back another layer of their mystery, proving that even in the void, nothing ever truly goes to waste. Beyond the known planets, in the frozen outskirts of our solar system, something massive is tugging at the fabric of our cosmic neighborhood. Astronomers call it Planet 9, a hypothetical world up to 10 times heavier than Earth, lurking so far from the Sun that it takes between 10,000 and 20,000 years to complete a single orbit. This isn't just speculation. It's a theory born from bizarre patterns etched into the orbits of distant icy bodies, anomalies so glaring they've convinced scientists something unseen must be pulling the strings. The clues began piling up in 2014, when astronomers Chad Trujillo and Scott Shepard noticed something odd about Sedna, a dwarf planet that orbits the Sun in a wildly elongated path, never venturing closer than 7.5 billion miles. Sedna shouldn't exist in such isolation. Its orbit defies the gravitational influence of Neptune and the other giants. Then came the real smoking gun, a cluster of smaller Kuiper belt objects, all tilted at roughly the same extreme angle, their closest approaches to the Sun strangely aligned as if choreographed. The odds of this happening randomly, less than 0.007%. Enter Caltech researchers Konstantin Batygin and Mike Brown, who ran simulations revealing an elegant solution, a distant, super-Earth-sized planet with an orbit tilted 30 degrees relative to the solar system's plane. Its gravity would act like an invisible hand, herding these smaller objects into their peculiar configurations. The math was so compelling that Brown, the same astronomer who demoted Pluto, declared, "We've only found 2 things in the solar system this big before. It'd be kind of weird if we didn't find this one." Yet the hunt has proven fiendishly difficult. At an estimated distance of 20 times farther than Neptune, Planet 9 reflects virtually no sunlight, rendering it invisible to most telescopes. Searchers have scoured infrared data from WISE, combed through decades of photographic plates, and even enlisted citizen scientists to scan telescope images, all turning up empty. Some argue the anomalies could stem from a primordial black hole no larger than a grapefruit, while others suggest observational bias in tracking Kuiper belt objects. But the theory adapts. In 2021, Batygin's team showed Planet 9 could explain another puzzle: why some distant objects orbit backward opposite the planet's motion. The hypothetical world's gravitational influence might flip them like a cosmic spatula over billions of years. Even Saturn's tilt might trace back to this phantom planet's ancient tug. For now, Planet 9 remains a shadow in the equations, a gravitational ghost waiting to be flushed from hiding. Upcoming telescopes like the Vera Rubin Observatory could finally spot its faint glow. Or perhaps, like Vulcan, the once theorized planet inside Mercury's orbit, it'll fade into history as a beautiful idea undone by better data. Either way, its legacy is secure, proof that even in our own celestial backyard, the cosmos still guards astonishing secrets. Most stars that flirt with supernova don't live to tell the tale, but LP40-365 isn't most stars. This celestial survivor, nicknamed the zombie star, did the impossible. It endured a blast powerful enough to rip apart a sun, yet clung to existence, now rocketing through the galaxy at over 2 million miles per hour like a bullet forged from stellar shrapnel. Discovered in 2017 by astronomers scanning for hypervelocity stars, this white dwarf should have been obliterated. Its story begins like countless others, a dense stellar corpse slowly cooling over billions of years. But somewhere along the way, something went catastrophically wrong. The leading theory, a runaway thermonuclear explosion, triggered when the white dwarf siphoned too much helium from a companion star. Normally, such an event would unleash a Type Ia supernova, annihilating the star entirely. Yet LP40-365 somehow weathered the blast, ejected with just enough mass to survive, but not enough to remain intact. The aftermath reads like a cosmic crime scene. Spectral analysis reveals an atmosphere composed almost entirely of oxygen, neon, and magnesium elements normally buried deep in a white dwarf's core. It's as if the star's outer layers were violently stripped away, exposing its scorched skeleton to the void. Even stranger, the zombie star's surface temperature soars near 50,000 degrees Celsius, hot enough to glow blue-white despite its traumatic past. But the real mystery lies in its velocity. Most hypervelocity stars are flung by interactions with supermassive black holes, yet LP40-365's trajectory points to no known galactic landmark. Instead, astronomers believe the supernova itself acted like a cosmic slingshot, with asymmetrical explosions launching the remnant star into its frenzied escape. Simulations show the force required would rival 1 trillion nuclear bombs detonating in unison, an explosion so precise. It spat out the star like a watermelon seed pinched between fingers. What makes this survivor truly unique is its fate. Unlike most white dwarfs that fade quietly, the zombie star is doomed to wander the galaxy indefinitely, its composition too exotic to follow conventional stellar aging. Over millennia, its blistering heat will slowly dissipate, leaving behind a cold, metallic husk, a tombstone for a star that cheated death, only to become a permanent exile in the cosmic dark. At the outer fringes of our solar system, where the sun's light dims to a faint glimmer, some astronomers believe a silent predator might be lurking, a dark, unseen star locked in a gravitational dance with our own. This hypothetical object, nicknamed Nemesis or the Dark Star, isn't just another cosmic curiosity. It's a theory that ties celestial mechanics to Earth's most catastrophic extinction events, suggesting the universe might have a way of resetting life's clock. The idea first gained traction in the 1980s when paleontologists noticed a chilling pattern in the fossil record. Roughly every 26 to 30 million years, Earth's biodiversity plunges in mass die-offs, events like the one that wiped out the dinosaurs. Around the same time, astronomers studying comet orbits spotted a peculiar trend. Long-period comets, those drifting in from the solar system's frozen outskirts, seemed to arrive in clusters. The connection, a hidden gravitational force, might be stirring the pot, nudging icy bodies from the Oort cloud into deadly trajectories toward the inner solar system. Enter Nemesis, a proposed red dwarf or brown dwarf orbiting the Sun at a staggering distance of 1 to 3 light-years. Unlike binary star systems where 2 suns shine brightly, Nemesis would be so dim, so cold, it could evade detection for centuries. Its gravitational pull, though subtle over such vast distances, might be enough to periodically disrupt the Oort cloud's delicate balance, sending comets hurtling toward Earth like cosmic bullets. The math was compelling enough that NASA launched the WISE telescope in 2009, partly to hunt for this elusive dark companion, yet decades of searching have turned up nothing. Skeptics argue that if Nemesis existed, its gravitational tug should leave imprints on nearby star motions, imprints we haven't found. Others point out that Earth's extinction cycles might simply reflect our solar system's bobbing motion through the Milky Way's crowded plane, where passing molecular clouds or spiral arms could trigger comet showers without needing a hidden star. But the theory refuses to die. In 2017, researchers examining the orbits of extreme trans-Neptunian objects found odd alignments suggesting an unseen perturber, though whether it's Nemesis, Planet 9, or something else remains hotly debated. Meanwhile, advances in infrared astronomy keep reopening the door. Brown dwarfs, especially old, cold ones, emit little light, making them nearly invisible to all but the most sensitive instruments. Could Nemesis be hiding in plain sight, camouflaged against the galactic backdrop? The most tantalizing question isn't just whether Nemesis exists, it's what its existence would mean for us. If the Sun has a silent partner, it transforms our solar system from a solitary star with planets into something far more dynamic, a binary system with a ghostly heartbeat. Every 26 million years, its return could herald chaos, sculpting not just Earth's history but the fate of any life clinging to its surface. For now, Nemesis remains a shadow in the data, a theory as haunting as it is unproven. Whether it's a celestial grim reaper or a cosmic mirage, one thing is certain: the universe has a way of reminding us how little we truly control, until the day telescopes catch its infrared glow. Or rule it out entirely, Nemesis lingers as astronomy's most chilling what if. Tucked away in the vast cosmic census of distant galaxies, astronomers stumbled upon something downright bizarre: tiny, glowing specks so vivid they earned the nickname green peas. These aren't your average star cities. Imagine a galaxy no larger than a tenth of the Milky Way, yet pumping out new stars at a rate that makes our home galaxy look downright lazy. First spotted in 2007 by volunteers sifting through Galaxy Zoo project images, these compact powerhouses glow an eerie green due to intense bursts of ionized oxygen, like cosmic fireflies flashing in the dark. What makes green peas extraordinary isn't just their hue, it's their resemblance to the universe's chaotic infancy. Most galaxies today form stars at a leisurely pace, their gas reservoirs depleted or locked away in stubborn dust clouds. But green peas, they're cosmic toddlers throwing tantrums, churning out stellar nurseries with reckless abandon. Some blaze so fiercely, they produce stars 10 times faster than the Milky Way, cramming enough stellar fireworks into a space smaller than the distance between our Sun and the nearest stars. The secret lies in their pristine gas. Unlike mature galaxies polluted by generations of supernova, green peas are relatively unspoiled, their hydrogen reservoirs still fresh and plentiful. This makes them near-perfect analogues for the universe's earliest galaxies, which also thrived in an era when gas was abundant and star formation ran wild. In fact, some astronomers believe studying these modern-day time capsules could unlock mysteries about how the first galaxies lit up the cosmic dark ages. But here's the twist: green peas shouldn't exist in today's universe at all. The conditions that birthed them were thought to have vanished billions of years ago, once the cosmos grew crowded and galactic collisions became the norm. Their survival suggests pockets of the universe somehow avoided the usual evolutionary script, preserving primordial conditions like bubbles frozen in time. Even stranger, a handful have been caught spewing out ionized gas jets strong enough to escape their own gravity, as if the galaxies themselves are bleeding starlight into the void. Perhaps the most tantalizing clue lies in their role as cosmic lighthouses. Because they're so bright and compact, green peas are ideal laboratories for studying how early galaxies enriched the universe with heavy elements. Each supernova within them scatters iron, carbon, and oxygen into intergalactic space, seeding future generations of stars and planets. In a way, these tiny green oddities aren't just relics. They're active participants in the universe's ongoing chemical evolution, proving that sometimes the smallest things hold the biggest surprises. At the heart of our spiral galaxy, hidden behind thick veils of dust and starlight, lies an enormous cosmic traffic jam, a dense, elongated structure called the galactic bar. Picture a colossal straight line of stars, gas, and dark matter, stretching 27,000 light-years from end to end, spinning like a slow-motion drill bit at the Milky Way's core. This isn't just a random quirk of celestial architecture, it's a gravitational engine shaping the destiny of billions of stars, including our own. For decades, astronomers debated whether such a bar even existed. The Milky Way's edge-on orientation makes direct observation nearly impossible, like trying to study the shape of a record album while holding it flat against your face. The breakthrough came in the 1990s when infrared telescopes pierced through the dust, revealing an unmistakable asymmetry, an excess of stars moving in sync along a rigid, rotating lane near the galactic center. Further studies confirmed it. Our galaxy isn't just a simple spiral, it's a barred spiral, one of the most common and chaotic designs in the universe. What makes the bar so fascinating is its role as a stellar conveyor belt. Its immense gravity acts like a cosmic spoon, stirring the galaxy's central regions. Stars and gas clouds caught in its pull get funneled inward, feeding the supermassive black hole at the center, while simultaneously triggering bursts of star formation along its length. Computer simulations show the bar's rotation creates shockwaves that compress interstellar gas, collapsing it into new stars at a rate that would put most spiral arms to shame. But the bar's influence doesn't stop there. Its gravitational ripples extend far beyond the galactic core, warping the orbits of stars thousands of light-years away, including our Sun. Some models suggest the solar system might have migrated inward from a more distant birth location, nudged by the bar's relentless tug. Even now, every orbit we complete around the galaxy brings us slightly closer to this invisible giant, though the timescales are so vast, we'd need a time-lapse spanning millions of years to notice the shift. The bar isn't static either. Like a spinning top gradually losing momentum, it slows over billions of years as its energy transfers to the surrounding disk. Some theories suggest this slowdown could eventually trigger a dramatic transformation, reshaping the Milky Way into a more relaxed, open spiral. Others speculate the bar might periodically dissolve and reform, a cycle tied to the galaxy's rhythm of star formation and gas consumption. Perhaps the most mind-bending realization, the bar we see today might not even be the first. Galactic archaeology hints at earlier bars that existed and dissolved long before our Sun ignited, their legacies written in the motions of ancient star clusters. It's a humbling thought. The very structure we're only now beginning to understand could be just one chapter in an ongoing saga of galactic reinvention. For all its grandeur, the galactic bar remains eerily elusive. Without specialized instruments, we'd never know it was there, silently orchestrating the dance of stars from the shadows. Yet its fingerprints are everywhere, from the newborn stars glowing in its wake to the subtle wobbles of distant suns. In a galaxy brimming with wonders, the bar stands as a testament to the hidden forces that sculpt the cosmos, reminding us that even the familiar Milky Way has secrets we're only starting to decode. In the vast archives of stellar explosions, supernovae usually follow a predictable script: blast, brighten, fade, leaving behind a neutron star or black hole as a calling card. But in January 2014, a star in the galaxy M82 defied the playbook entirely. Catalogued as SN 2014c, this explosion erupted with the usual fanfare, then performed a cosmic vanishing act so complete, astronomers are still scratching their heads. The first red flag came when telescopes swiveled toward the aftermath. Typical supernova remnants, like the Crab Nebula's swirling filaments, linger for millennia, glowing with the energy of their own decay. SN 2014c It faded into near invisibility within months, leaving no pulsar, no black hole, not even a wisp of glowing gas. It's as if the star didn't just die, it erased itself from existence. The plot thickened when researchers dug into pre-explosion images. The doomed star wasn't a massive supergiant, as expected, but a modest sun-like star, one theoretically too small to go supernova at all. This paradox sent theorists scrambling. One leading explanation suggests the star was actually part of a binary system, its more massive companion having already collapsed into a black hole. Over time, the black hole siphoned away the smaller star's outer layers, leaving behind a helium-rich core. When this core finally detonated, the explosion lacked the usual radioactive elements that make supernova glow brightly, resulting in an ultra-stripped event that left almost no trace. But here's where it gets stranger. Delayed observations in radio and X-ray wavelengths revealed something odd, a faint echo of material hurled outward years after the initial blast. It's as if the star's death throes came in waves, with later eruptions pushing gas into space silently, without the fireworks. Some models propose the core might have briefly reformed as a neutron star before collapsing further into a black hole, creating a secondary shockwave that evaded optical telescopes. The most unsettling implication, SN 2014c might not be alone. Recent surveys suggest up to 10% of supernova could be similarly empty, their remnants too dim or too fleeting for current instruments. If true, it means we've been missing an entire class of stellar deaths, ones that leave behind ghosts instead of monuments. For astronomers, this isn't just about one oddball explosion. It's a window into stellar mortality's secret menu, where stars can die quietly, violently, or in ways we haven't even imagined. In a universe that loves spectacle, SN 2014c whispers a humbling truth: some endings aren't meant to be seen. At the crossroads of stellar evolution, where dying stars defy expectations, there's a cosmic chimera so strange that for decades it existed only on paper: the Thorne-Zitkow object. Picture a red giant, one of the universe's most bloated stars, stretching hundreds of millions of miles across, but lurking at its core isn't the usual helium furnace. Instead, a city-sized neutron star spins silently, wrapped in layers of searing gas like a Russian nesting doll from the depths of space. This isn't just a star with an exotic heart. It's a gravitational paradox, a celestial oddity that shouldn't survive its own contradictions. The idea was born in 1975 when physicists Kip Thorne and Anna Zitkow calculated an improbable scenario. What if a neutron star, the collapsed remnant of a supernova, got swallowed by a red giant during a close stellar dance? Normally, such a collision would tear both stars apart in a cataclysmic explosion. But their models showed that under razor-thin conditions, the neutron star might endure, sinking to the red giant's core over millennia. There, shielded by layers of hydrogen, it would feed on the surrounding gas, altering the star's chemistry in ways no natural process could replicate. For years, the Thorne-Zitkow object remained a beautiful hypothesis. Then, in 2014, astronomers spotted a candidate, HV 2112, a star in the Small Magellanic Cloud. Its spectrum blazed with excess rubidium, lithium, and molybdenum, elements typically destroyed in red giants, but which neutron star cores could theoretically forge in abundance. Here was a star with the fingerprints of a cosmic cannibal, its atmosphere polluted with the byproducts of extreme nuclear reactions. Yet the discovery came with caveats. HV 2112's neutron star core hasn't been directly observed. Its existence is inferred from chemical clues, leaving room for alternative explanations like unusual stellar mergers. Finding more candidates is devilishly hard. Thorne-Zitkow objects would masquerade as ordinary red giants to all but the most sophisticated telescopes. Their telltale signatures, overabundant heavy elements and subtle pulsations, could easily be drowned out by cosmic noise. Even their lifespans are uncertain. Some models suggest the neutron star might eventually spiral fully into its host, triggering a supernova. Others propose the red giant's outer layers could be stripped away, leaving behind a bizarre neutron star white dwarf binary. What makes these hybrid stars so tantalizing isn't just their rarity, it's what they reveal about stellar extremes. A Thorn-Zitkow object's core would experience conditions unimaginable even in lone neutron stars, temperatures and pressures so extreme they might produce exotic particles or states of matter unseen anywhere else. Meanwhile, the star's outer layers would churn with nucleosynthetic chaos, potentially seeding the galaxy with rare isotopes. They're cosmic alchemists turning ordinary stellar material into cosmic gold, literally. Yet the hunt continues, with astronomers scouring stellar surveys for more HV2112-like anomalies. Every candidate could rewrite our understanding of how stars live, die, and sometimes cheat death by becoming something entirely new. Until we find definitive proof, Thorn-Zitkow objects remain the universe's ultimate stellar sleight of hand, a reminder that even the wildest theories might be hiding in plain sight, waiting for us to look closer. Galaxies aren't supposed to move like this, drifting through the cosmos, entire clusters of them, thousands, millions of suns should follow the gentle tug of the universe's expansion, flowing outward like leaves on a slow river. But something far stranger is happening. Across the sky, galaxy clusters are racing in the same direction at breakneck speeds, as if dragged by an invisible current. Astronomers call this eerie phenomenon the dark flow, and it hints at forces beyond the edges of everything we can see. The discovery came in 2008 when researchers studying the cosmic microwave background, the afterglow of the Big Bang, noticed something unsettling. By analyzing subtle distortions in this ancient light, they could track the motion of galaxy clusters. What they found defied all expectations. Nearly 700 distant clusters were hurtling toward a single patch of sky near the constellations Centaurus and Vela at speeds exceeding 2 million miles per hour. This wasn't random drift, it was a coordinated march, as if some colossal structure outside our observable universe was pulling them like a magnet. The implications sent shockwaves through cosmology. According to Einstein's theories, nothing, not even gravity, should influence objects beyond the cosmic horizon, the point where expansion pushes galaxies away faster than light can reach us. Yet the dark flow suggests something massive is tugging on us from the other side. One theory, our universe might be just one bubble in an infinite multiverse, and these galaxies are feeling the gravitational whisper of another bubble's matter, a neighboring cosmos brushing against ours like a ghost in the dark. Skeptics argue it could be a measurement error or an illusion caused by uneven radiation, but the signal persists even in newer studies. Some simulations show superclusters of galaxies might create their own gravitational currents, though none match the scale of the dark flow's eerie coherence. Others propose an even wilder idea: the remnants of space-time's violent birth, a primordial imbalance left over from the Big Bang itself, could be warping the cosmos on scales we're only beginning to sense. Whatever the cause, the dark flow is a humbling reminder. The universe we see, the stars, galaxies, even the cosmic web, might just be a speck in something far grander, its true shape and size forever hidden beyond the veil of light's reach. And if we're being pulled, who or what is doing the pulling? Somewhere beyond the stars, hidden behind the thick curtain of the Milky Way's galactic plane, a gravitational nightmare stirs. It's called the Great Attractor, an invisible cosmic maelstrom so powerful, it's dragging entire galaxy clusters toward it at millions of miles per hour, bending the fabric of the universe itself into an inescapable current. And the most unsettling part, we can't even see it. This colossal mystery lies roughly 250 million light-years away in the direction of the constellation Centaurus, buried deep in what astronomers call the zone of avoidance, a region of sky obscured by the Milky Way's own gas, dust, and stars. Imagine trying to spot a lighthouse through a thunderstorm. That's the challenge scientists face when probing this gravitational enigma. The Great Attractor's pull was first detected in the 1970s when astronomers noticed something bizarre. Galaxies in our local supercluster, including our own, weren't just drifting apart with the universe's expansion. They were all racing toward the same invisible point, like leaves caught in a cosmic whirlpool. But what could exert such force? Initial estimates suggested the Great Attractor's mass was equivalent to tens of thousands of Milky Ways, enough to warp space-time on a scale usually reserved for galaxy clusters. Yet when X-ray telescopes like Rosat pierced through the zone of avoidance in the 1990s, they found only a fraction of that mass in visible matter. The rest had to be something else, dark matter woven into an unseen scaffold, or something even stranger. Then came the plot twist. As observations improved, astronomers realized the Great Attractor might not be the ultimate destination after all. Our local galaxies aren't just flowing toward it, they're being pulled through it toward something far larger and more distant. The Shapley supercluster, a staggering concentration of mass 8 times farther away. This titanic structure, containing over 20 massive galaxy clusters, appears to be the true endgame of this cosmic river. The Great Attractor, just a waypoint, a ripple in the current. Yet the questions multiply. Why is space so lopsided here? Why does one region wield such disproportionate gravitational influence? Some theories suggest the Great Attractor is a knot in the cosmic web, where filaments of dark matter intersect, amplifying gravity's grip. Others speculate it could be the echo of an ancient collision between superclusters, a wound in space-time still healing. What's certain is this: the universe isn't just expanding, it's flowing, and we're caught in its tide. Every galaxy, every star, even the light from the Big Bang itself is being tugged by forces we're only beginning to map. And somewhere beyond the veil of dust and stars, the Great Attractor remains a silent puppeteer, reminding us how little we truly see. Deep beneath the Antarctic ice, where temperatures plunge to unbearable lows and darkness reigns eternal, a telescope unlike any other keeps watch. The Ice Cube Neutrino Observatory isn't peering into the sky, it's staring straight down, waiting for ghostly messengers from the cosmos to whisper their secrets. And on September 22, 2017, one of those phantoms finally spoke. This wasn't just another subatomic flicker in the detector. Ice Cube 170922A, the neutrino that would change astronomy forever, carried an energy of nearly 300 trillion electron volts, more than 40 times the power of protons in the Large Hadron Collider. But its significance wasn't in its strength. It was in its origin. For the first time in history, scientists traced a single neutrino back to a cosmic monster 4 billion light-years away, a blazar known as TXS 0506+056, a supermassive black hole spewing jets of plasma straight toward Earth. The discovery marked a watershed moment, the explosive birth of multi-messenger astronomy. Before this, we studied the universe through light alone, limited to what photons could tell us. But neutrinos, these elusive particles, nearly massless and almost untouched by matter, slip through entire planets like they're not even there. They're cosmic fugitives carrying stories from places light can't escape. And this one was a smoking gun, pointing directly to one of the universe's most violent phenomena. Blazars like TXS 0506 are galactic power plants. As their central black holes devour gas and stars, they launch twin jets of charged particles at nearly light speed. When one of those jets happens to aim right at us, the effect is staggering, a celestial blowtorch so intense it outshines entire galaxies. But until Ice Cube 170922 arrived, no one could prove these jets were also neutrino factories. The neutrino's detection, followed by a frantic scramble of telescopes worldwide, confirmed it. Those jets aren't just hurling radiation, they're accelerating particles to energies that defy comprehension, creating neutrinos as byproducts of cosmic destruction. What makes this story even richer is how the pieces fell into place. Ice Cube's alert triggered observatories across the electromagnetic spectrum, gamma-ray telescopes, X-ray satellites, even radio arrays. Each one turned toward the blazar, capturing its flare in real time. The data painted a portrait of chaos, the black hole's disk convulsing, magnetic fields snapping like rubber bands, and particles surfing shockwaves to unimaginable energies. It was astronomy transformed from a solitary detective's work into a global manhunt with neutrinos as the tip-off. Yet the implications go far beyond blazars. Ice Cube 170922 proved that neutrinos can be cosmic signposts, guiding us to hidden sources of extreme physics. They might lead us to dark matter annihilations, neutron star mergers, or phenomena we haven't even named yet. And with upgrades like Ice Cube Gen 2 on the horizon, capable of catching 10 times more neutrinos, we're on the brink of an era where these phantoms become our eyes, revealing a universe we've only ever glimpsed in the dark. For centuries, astronomy was shackled to light. Now, thanks to a single ghostly particle that pierced the Antarctic ice, we've unlocked a new way to see, and the cosmos will never look the same. Right now, as you read this, a silent interloper is creeping toward our solar system, not a rogue planet or a wandering black hole, but a seemingly ordinary star called Gliese 710. This unassuming orange dwarf, currently gliding through the constellation Serpens, carries a startling prophecy. In roughly 1.3 million years, it will pierce the frozen frontier of our solar system, coming closer than any other star in recorded astronomical history. And when it does, its gravity could unleash chaos on a scale we've only glimpsed in simulations. Discovered in the early 1990s and refined by Gaia satellite measurements, Gliese 710's trajectory is no theoretical curiosity. Current calculations place its closest approach at just 16,000 astronomical units, a hair's breadth in cosmic terms. That's closer to the Sun than the inner Oort cloud, that vast reservoir of icy bodies where comets lurk in the dark. To put that in perspective, our current closest stellar neighbor, Proxima Centauri, sits over 260,000 astronomical units away. Gliese 710 won't just pass by, it'll wade knee-deep into the solar system's gravitational shallows. The consequences could be dramatic. As the star plows through the Oort cloud, its gravity will act like a cosmic fishing net, disturbing countless icy objects. Some will be flung outward into interstellar space, others hurled inward toward the Sun. Statistically, this stellar intruder could increase the rate of long-period comets entering the inner solar system by a factor of 10 for millions of years. Imagine a celestial hailstorm with frozen relics from the solar system's birth suddenly raining down on planets that have known quiet skies for eons. But here's the twist: Gliese 710 isn't just passing through, it's moving slowly. Unlike hypervelocity stars that zip through galaxies at breakneck speeds, this interloper is taking its time, lingering in the solar system's gravitational neighborhood for tens of thousands of years. That prolonged presence means its disruptive effects won't be a one-time event but a drawn-out siege, with each gravitational nudge sending fresh waves of comets spiraling toward the inner planets. The timing couldn't be more ironic. By the time Gliese 710 arrives, humanity, if we still exist, might have spread across the solar system. Colonies on Mars or floating cities in Venus's clouds could find themselves in the crosshairs of a celestial billiards game they never saw coming. Yet there's a poetic symmetry here too. The same Oort cloud perturbations that might threaten future civilizations could also be the very mechanism that delivered water-rich comets to Earth in our planet's youth, kickstarting the conditions for life. What makes Gliese 710 especially haunting is its inevitability. Unlike hypothetical threats like asteroid impacts or solar flares, this encounter is already locked into the cosmos's clockwork. The star's path, refined by precision astrometry, leaves little room for doubt. The only question is what or who will be here to witness it. Will we be long gone, our traces erased by time? Or will our descendants look up at a night sky where two suns drift close enough to share the same constellation, bracing for a celestial winter that lasts millennia? For now, Gliese 710 remains a faint speck, invisible to the naked eye. But its silent approach is a reminder: the universe is never truly still, and even the most distant stars can rewrite the future of worlds they never touch. We've ventured through a gallery of cosmic oddities, each one stranger than fiction, each one rewriting the rules of what we thought was possible. From the diamond-crusted corpse of a devoured star to the invisible hand of the great attractor, the Milky Way isn't just a collection of stars, it's a theater of the absurd, where physics takes on forms so bizarre they border on magic. Yet for every mystery we've unraveled, a dozen more lurk in the shadows, whispering questions we're only beginning to ask. Think about it. We live in a galaxy where dead stars pulse like lighthouses, where entire planets might be carved from gemstones, where black holes flicker with the light of annihilated antimatter. And somehow, against all odds, we're here to witness it not as distant observers, but as part of the story. Every one of these objects is a puzzle piece in a grander picture, one that stretches from the quantum to the cosmic. But here's the humbling truth: we've barely scratched the surface. For every object we've catalogued, there are countless others waiting to defy our expectations. Maybe you're fascinated by the rogue planets adrift in the dark, or the eerie silence of Tabby's star, or the way the universe seems to flirt with impossible geometries in Hoag's object. Whatever cosmic mystery grips your imagination, remember, the universe isn't just stranger than we imagine, it's stranger than we can imagine. So what's next? That's where you come in. The night sky isn't just for astronomers, it's for anyone willing to look up and wonder, which of these cosmic enigmas left you awestruck? Share your favorites in the comments, and let's keep the conversation as boundless as the cosmos itself. And if you're hungry for more deep dives into the universe's greatest mysteries, don't forget to hit subscribe, because the next discovery might be even wilder than the last. The Milky Way's secrets aren't locked away in some distant corner of space. They're unfolding all around us, waiting for the next curious mind to connect the dots. Who knows, maybe the strangest object of all is still out there, hidden in plain sight, just waiting for its moment to rewrite the story. Keep looking up. The universe isn't done surprising.